Hello, this is Unit 4, Module 3, Session 2. The name of this home connection is Which Measurement is Best? It is a two-pager. Put your name and number at the top, please. Get credit for all this hard work. We've been talking about different ways to measure things around us. Over here, I just did some drawings just to put things in perspective. Let's see, in my pocket, I think I have, yes I do, a quarter for reference. But if you take a look here, an inch is about the width of a quarter. It's a little bit bigger than a quarter, but just think about that. A quarter is about an inch in diameter, okay, from side to side, okay? A centimeter is going to be quite a bit smaller than an inch. And a millimeter, can you even see that? Should I zoom way in? Look at that. That millimeter was so hard for me to draw. It's from that tiny line to this tiny line is a millimeter. So that bad boy is tiny. A millimeter, oh my goodness, that's about the width of the tip of my pen is a millimeter. So that's just for reference for this activity, okay? So you're supposed to say which measurement is best. So if I'm thinking about the height of a ceiling, okay? So think about from the floor of your room up to the roof of your room, right? Is that 10 inches tall? So like if you stacked 10 inches or 10 quarters on top of each other, is that tall enough to get to the ceiling? 10 feet, okay? So if you think about the average height of a man is about 6 feet tall. So maybe if I said like this guy here, he's about 6 feet tall, okay? And then here would be the ceiling, okay? So there's a little bit of space there. 10 meters is really close to about 30 feet. And I want you to think about maybe like how tall it is in your gymnasium, like in your gym. Because it takes about 10 feet to get to a basketball hoop, right? Let's say this was the basketball hoop. And then you've got the ring here, right? That's your basketball hoop. That's about 10 feet there. And then way up to the roof of your gymnasium is about 10 meters. And then 10 centimeters is less than 10 inches. I can show you on this ruler where 10 centimeters is. Would be from here to here, right? My pen is longer than 10 centimeters. So which of these is the best estimate of how high my ceiling is? Well, to me, I'm thinking, well, man, that's got to be about 10 feet. Because if a man is 6 feet tall and he can almost reach the ceiling, that's going to be a few more feet. So that's 10 feet. The length of a mouse. First off, we have to figure out which ones of these are length. Okay, feet, that's how long something is. Ounces, no, that's like liquid. We're not measuring liquid. Like you could have ounces of juice, right? We're not measuring juice. Centimeters, that's how long something can be. Yards, that's how long something could be. What unit would you use to measure this mouse? Okay, and I can zoom out for a second. This ruler that I'm holding right here is 1 foot long. Should I measure it using feet? Well, it's not even 1 foot. It's way less than 1 foot. I also have centimeters as an option, and I do have centimeters on my ruler. So from here to here, it's about 11 centimeters, if I count these centimeters on this side of my ruler. And then if I was measuring in yards, that's how big a football fields are measured in yards, because 1 yard is 3 of these rulers. So 1 yard is 3 foot rulers. Okay, you may have even seen a yard stick. It would be 3 of these together. So if I was going to measure this, what would I use? Personally, I think it would be handy if you used centimeters, because you can get really specific. Is it 10 centimeters, 11 centimeters? But it's not even 1 foot, so it's definitely not even 1 yard. So that your best bet would be centimeters. Help me out with this next one. It says, what is the best estimate of the distance across your classroom? Okay, so I've got a few different options here. I've got 30 meters and 30 yards. These are going to be very similar to each other. 30 yards is the same as 90 feet. Okay. 30 feet would be like 30 rulers across. 30 kilometers. Kilometers are similar to miles. Miles are longer, but kilometers are pretty close. So 30 kilometers, I don't know about that. To get from one end of your classroom to the other doesn't quite make sense to me. So I would not choose kilometers. And then the only thing that you have to do is to figure out, am I working with maybe feet, 30 feet, 90 feet? 30 meters and 90 feet are pretty close. I'm going to let you ponder that for a little bit, okay? Which of these units would be the best measure? Let me read that correctly. Which of these units would best measure the length of a ladybug? And ladybugs are about this big. Okay? That's about how big a ladybug is. Guess I could probably doodle a little bit, just so it looks nice. How am I going to measure that? It said the length. Millimeters are length, inches are length, grams, ooh, that's mass. Cannot use grams, and feet is length. So if I took my ruler and I wanted to measure it, let's say that I use millimeters. Looks like, from here to here is about maybe about 6 millimeters. If I use inches, oh man, I don't even get up to 1 inch. That might not be very helpful. And then if I use feet, I mean, that means I have to use the whole ruler. How much of this whole ruler is this ladybug? Oh man, I'm going to have a really weird fraction, right? So I have an idea about what I would use for it, but I want you to try to be logical about it and choose what you think would be the best way to measure this. Number 5, which of these units would best measure the length of a pair of scissors? I do have a pair of scissors right here. My options are grams, ounces, feet, centimeters. Grams is mass, ounces is volume. We're talking about length here. We can't use these two. So you have to tell me, would you measure it in feet or centimeters? And if I do this for you, let's say that I put my ruler up against it. It is, oh wow, way less than a foot. So I know it's less than 1 foot. If I measured in centimeters, let me flip my ruler over. From end to end, it's about, let's say, that looks like 19 centimeters. Which is going to be more accurate? Would you tell somebody, yeah, it's smaller than a foot, or would you tell them, oh, it's 19 centimeters? And I think my tone gave it away. But if you want to be specific, 19 is really helpful. Saying less than a foot, it's more than half of a foot, something like that. It's not very specific. I would go with centimeters. 4 more questions. The distance across the state in which you live. All right? And Nebraska's got several hundred miles in it. So I want you to tell me, would you try to count yards? Oh, you can't do gallons? That's liquid. That's measuring volume. You can't do ounces, right? We're not doing, if it's fluid ounces, that's volume. But if it's weight ounces, that's still weight. That's not length. It says the distance across. That's length. My only options are miles or yards, and I'm going to let you answer that question. Number 7 says Kim was using a give and take strategy. Ooh, this is an addition problem, so it has to be give and take. Fill in the blanks to make the equation true. So it looks like I've got my first number, and maybe I could do this in colors. I've got a first number and a first number, and maybe red. I have a second number and a second number. Okay, I like to color code these so I know where I'm going. And it looks like the question we're going to have to ask is how do I turn 999 into 1,000? I'm hoping that you say the answer is to add 1. But we know that if we're doing a give, on the other side we have to do a take. So if I give 1 in an addition problem, I have to take 1 in an addition problem. So if I take 1 away from 587, what do I get? 586. Is it a little bit easier to add these two numbers now? Because now you can give me the answer, 1,000 plus 586. Write the answer here. The nice part is, even if you didn't, let's say you just forget this half, and you were just given this problem, that is still going to be the same answer as doing this problem right here. Because we used our strategy appropriately, give and take. Okay? Kevin was using a constant difference strategy. Difference means we're working with subtraction. Fill in the blanks to make his equation true. So if I go back to my colors and I do the first number in the same color, and then I do the second number in the same color, now I can track what's going on here. I have 1,256 is turning into some number, but I don't know what it is. But I do know that 799 turns into 800. How does 799 become 800? You need to add 1. Now, the rule is, if you are using difference, you must use give or take, which I'm going to write up here just so you can see it. Give or take. Okay? Up here, when you see addition, you can only use give and take. Give to one, take from the other. So, what happened? I gave a 1 to 799. That turned it into 800. So if I give to one, I must give to the other, the exact same amount. So I'm also going to add 1 to the other number. Once I add 1, I get 1,257, and then I can subtract 800. And you can use whatever strategy you want. If you want to do the stack and add, or stack and subtract, please do. That turns out pretty good because you only have to borrow 1 time. Okay, but I will let you finish that one on your own. Finally, in number 9, Owen had 3 different kinds of stickers that he wanted to put on, I should probably zoom out, that he wanted to put on paper. He put a bird sticker on every 30th paper, a sports sticker on every 50th paper, and a robot sticker on every 60th paper. Will any of the first 600 pages have all 3 stickers? If so, which pages? Dang, this is hard. And you know what's crazy about this? Is that we could shorten it a little bit, and maybe I'll do that second. But for right now, what I am going to do is I'm going to give us just a couple number lines to work with so that we can see how the numbers progress. Give me a number line there, number line there, and I'm going to come down and put another one below that. Okay, so we're going to say that here we're working with every 30th, here every 50th, and here every 60th. Okay, and they all start at 0. So you start at 0, start at 0, start at 0. And so what is it? So what are we doing? So when I get to page 30, I'm going to put a sticker. And then another 30 pages gets me to 60, and then I put a sticker. And then every 30 pages I go to 90. And then another 30 is 120. And then 150. And then 180. And this pattern is going to go on. So I'm counting by 30s. So I put a sticker on page 30, page 60, page 90, page 120, page 150, 180. Do it going by 50s. So I'm going to put one on page 50. I'm going to put one on page 100. Add another 50, you get 150. Add another, you get 200, and then 250, and so on and so forth. I already see that we have one common number. That might be a happy accident. Let's find out. Start at 0 and count by 60s. I've got a 60, I've got 120. Add another 60 and you get 180. Oh, look there. Those two line up. And so far, nothing is working. Darn, 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 darn. So that means I have to keep going if I want to use trial and error. So let's just keep going and see what happens. 180 gives us a 200, what is that, 10, plus a 240, plus a 270. Ooh, I gotta keep going. Plus a 300. Wow, I can get all the way to 300, counting by 30s. Okay. If I go by 50s, I get to 200, and then I get 250, 50, and then I get, oh look, 300. So those line up. That's nice. 0, 60, 120, 180. Let's see. Then I have 240, and then I have 300. So if I go 1, 2, 3, 4, 5 times 60 is 300. So will any of the first 600 pages have all 3 stickers? If so, which pages? Well, I can keep going like this forever and ever, but this is kind of hard work to count by multi-digit numbers, 30s, 50s, and 60s. I could do the exact same thing if I remove a 0 from every number. So if I say every 3rd paper, every 5th paper, every 6th paper, will any of the first 60 pages have all 3 stickers, and if so, which ones? And this is where I have to get out my math notebook. But where'd you go, Math Turtle? Sorry, it was not where I thought it was. But let's do this on just a little piece of paper right here. I've got some graph paper, okay? So, if I were to take my numbers, I'm going to do every 3rd paper, every 5th paper, and every 6th paper. So I'm just going to count by 3s, 5s, and 6s. Right? 3, 6, 9, 12, 15, 18, let's see, 21, 24, 27, 30, 33, 36, 39, 40, what, 2, what is that, 40, yeah, 42, 45, 48, 51, 54, 50, what do we have after that? 57, and then 60. Okay, I got all the way to 60, counting by 3s. Whew. Do the same thing with 5s, trying to get to 60. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay? Do the same thing by 6. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Each one of these numbers will get me to 60. But how many of them share the same number along the way? We decided that you can get to 30, and that is all. So the only thing that will happen is you will you'll put a sticker on page 30, and then you will put a sticker on page 60. But if you put the zeros back in, it's page 300 and page 600. So I made tables, ratio tables if you want to, or just your regular times tables, to figure out which numbers are in common. We found common factors. Now, here's the fun part. If I take 5 times 6, what do I get? 30. If I take 3 times 5, what do I get? 15. Those numbers relate to each other. You can use common factors among them to find patterns, which could be helpful. The only issue is that, like, if you take a 6 times 3 and you get an 18, that's going to be a little bit more difficult to be useful along the way. So you got to be a little careful if you're going to multiply to find common factors. Okay? Whew. So that question took a long time, but man, it is so interesting. So what was the answer? Will any of the first 60 pages have all 3 stickers? You'd say yes on pages 300 and 600. The end. Okay? If you have questions about how any of these questions work, please find a trusted math wizard. Teachers really like to answer questions. You can take any of them to them. Make sure you finish any of the questions that you maybe forgot to pause on. Go back, fill them in, and then go strut your stuff and show off what you know. Check you later.